Hi, I'm Thomas Paul from Huber+Suhner. We're here at the Satellite Show in Washington, D.C. I'm the market manager for Aerospace, and I'm going to show you a new capability that we've launched. It concerns board-to-board connections, and it concerns hybrid connectivity. And what you're looking at here under the microscope is a board-to-board connection that comprises both RF, here on the left and on the right, RF coaxial connections, and 8 DC pins through the middle. Now these micro machine parts are very compact, obviously. They combine these technologies that permit customers to reduce their footprint, their integration sizes dramatically when they're connecting boards. Now this is a customized product, but what we're really advertising here is the capability to make these sorts of things, right? So if you have needs that require different dimensions, different numbers of links, different DC or RF connectivity solutions, then come to us, we will find a solution, and we're able to manufacture these at very large volumes, constellation grade. Hi, I'm Thomas Paul. I'm the market manager for Aerospace for Huber+Suhner. I'm here at the Satellite Show in Washington, D.C. And one of the things we're showcasing on our booth this time is our CT technology, constant over temperature. That's coaxial cables that are invariant in phase with respect to temperature. These sorts of coaxial cables are important when you're dealing with phase critical applications like synthetic aperture radars or beamforming, or in general electronically steerable arrays. Now a coaxial cable is usually used to connect these instruments, and these coaxial cables in general are sensitive to temperature changes what concerns the output signal phase. So that signal phase will shift as the temperature changes. And the reason for that is the construction of the cable and the choice of materials. It's differential thermal expansion coefficients, it's phase transitions in PTFE that typically lead to a dramatic and abrupt shift in the output signals phase. And these effects can be mitigated by adapting the cable construction and materials. And that's what we've done. So if you take a look here, we've got a setup where we compare our CT technology with a conventional coaxial cable from us. Now both cables are hooked up to a VNA, and what you see here on this VNA is the phase as a function of frequency. And what we're going to do is we're going to cool down these cables, change the temperature, and see what happens to the phase. Now what you see happening here to the lower trace is the phase is drifting away in phase space, and that's the phase that we're recording for the cable that does not have CT technology. The other one remains flat. Now if you have a phase critical application, then that's exactly what you want to have. You want to have a passively stable cable that allows you to not have to deal with homogenizing the thermal environment around your cable or having to actively compensate for any phase drifts that you see.